Okay, these are the examples from section 4.1 in your note packet that we didn't get a chance to go over in school today. So all we're going to do when we have figures like this is we're going to go kind of around like it's a puzzle, and we're looking for linear pairs, vertical angles, and isosceles for the most part right now. So if I want to solve, for example, angle 1, I see that these two angles together make a linear pair. So 180 minus 150 is simply 30 degrees. So angle 1 is 30 degrees. Then I also see, here's another linear pair, angle 2 and angle 9. Together they make a linear pair, which is 180. So 109 or 180 minus 109 is 71 degrees. So that's a 71 degree angle. Now, I do have a triangle that I can do to solve for 4. I see that this is simply a 90 degree or a right triangle. So all triangles equal 180. So I have a 71 degree angle, a 90 degree angle, so I can subtract them from 180, and I end up getting a 19 degree angle over here at angle 4. I also have another triangle right here. I have a green triangle for angle 3. So that is another right triangle. So 180 minus 90 and minus 30 is going to give me a 60 degree angle. Okay, and you can fill in those at the top. So example number 2. Example number 2. So I noticed, first thing I want you to notice is we've got a lot of parallel lines going on. Usually when you see parallel lines in a figure, you're going to use all of your rules like corresponding angles, alternate interior angles, alternate exterior angles, and all of those rules that you know. So I'm just going to kind of go around this piecemeal and see what we can find. So we're looking for R, S, and T, but I'm going to have to figure out a lot of other angles before I can get there. So, you know, there's nothing I can use directly to get to R, S, and T. So I see, first of all, I have a vertical angle. So this is also 100 degrees. The next thing I notice is that these two angles are equal, and this is a triangle that equals 180. So 180 minus 100 leaves me with 80 degrees. So I'm going to split that in half, and this is going to be a 40 degree angle and a 40 degree angle, because 40 plus 40 plus 100 is 180. The next thing I'm going to do is, now I'm going to I'm looking at my parallel lines. I'm going to use some parallel lines now. So I'm going to highlight some parallel lines for you in pink. So these pink parallel lines have a transversal cutting through them, right? So this transversal cutting through that particular set of parallel lines is actually going to get me angle S, because I want you to notice this angle right here and this angle right here are corresponding angles. So angle S has to also be 40 degrees. Remember, corresponding angles, when we line them up like this angle and this angle are corresponding angles. They have the same position. So this is, in this group of angles, this is my upper left and this is my upper left, so that has to be 40 as well. The next thing I'm going to do is I'm going to highlight a different set because I can't seem to go anywhere else with that. So I'm going to highlight my other lines, and I'm going to put my transversal through that. So if you just focus on the green lines now, so let's just look at the green lines, can you see that this angle, which is my lower left and my lower left, those are also corresponding angles, so this has to be 100 degrees. So corresponding angles are congruent. These two, if you just focus on the green lines, have the same position, so they're both 100 degrees. And then I have a nice little triangle here, which has to equal 180. So 100 plus 40 is 140, subtracted from 180, so this also has to be a 40 degree angle. So we've just answered what all of them are. Okay. A couple more examples. And this is example 3. So the first thing I want to notice is that I have a triangle. So you see the triangle, and all triangles equal 180, right? They equal 180. Sometimes I write that 180 in the middle of a triangle just to remind myself that that's what it's going to equal. So 180 inside. So I know that I can add these all up, right? Isn't 30 plus 4x plus 100 minus x plus 7x equals 180. So I'm going to underline those so you can see them. So I have one angle, two angles, and three angles. You have to add them all up, and they equal 180. So I can combine all my like terms, and I get 10x plus 130 equals 180. And when you finish solving that, you end up with x equals 5. Another thing, sometimes instead of writing all this out, sometimes what I'll do is I can just look at all my terms, at my like terms, and I can combine them. So I have 130, so that's my 130, and then I have a 4x, a 7x, minus x, so that is my 10x. So 4 plus 7 minus 1 is going to give me 10x. So if you don't have to write them all out, but you do need to add up all your like terms. Notice that this y has nothing to do with the 180, it has nothing to do with the inside of the triangle. But I am going to use it to solve for y. Because if I know this is x, if x is 5 rather, I can plug that in for this this x here. So I know that this is a 35-degree angle. 7 times 5 is 35. And this, let me use my highlighter, this is a straight line. So it equals 180. Sometimes it helps students to kind of make this arch when you see a straight line so that you make sure that you connect all your angles. Sometimes you'll get to examples where there might be 3 angles that make a straight line. So I'm going to do 180 minus 35, and I end up getting 145. So y is 145 degrees. Okay, 2 more examples. This is example 4. So the first thing I'm going to do is I notice that I have, if I just look at this triangle here, this is an isosceles triangle, right? So we learned about isosceles triangles today. So we know that if we have an isosceles triangle, if I want, I can mark it as isosceles, like with our marks that we're familiar with. We also know that in an isosceles triangle, which equals 180, right? All triangles equal 180, that our base angles are also the same. So if you have an isosceles triangle, the angles opposite are going to be equal. So I know these are equal. So if this all equals 180, what I can do is 180 minus 42 is 138 degrees. So these 2 angles together have to add up to 138. So I'm going to divide by 2, and I end up getting 69 degrees. So this is a 69-degree angle. This is a 69-degree angle. 69, 69, and 42 is 180. So if I come over here, I have vertical angles going on here. So this is a 42-degree angle. So again, I'm just looking at this triangle here. So I also know that these all have to add up to 180. So 42 plus 96 is 138. And minus 180 is going to be 42. So this is also a 42-degree angle. 42 plus 96 is 138. And then 180 minus 138 is 42. So notice that these 2 angles are equal. So our rule about isosceles triangles, where we have an equal side, equal angle, works in reverse as well. So it works both ways. So if I have equal angles, then my 2 opposite sides are equal. So 42 goes with 3, and then this 42 also goes with 3 as well. Because the question up here is find the length of C to E. So we wanted to find just this length right here. These have to be the same. So we answered what angle D is, and we answered what angle A is. Okay, one more example. So we want to think about this triangle, and we're looking at points. So this point, this vertex, is at the point -5, -1, and this point is at 1 comma something. So notice that these 2 lines are parallel. So if they're parallel, we already know that the x-axis has a 0 slope, right? There's no incline. It goes straight across, so it's a 0. So this also has to have a 0 slope. So if I go from the point -5, -1, and I just want to go straight over, aren't all of these points going to have a y coordinate of -1? So this is going to be at 1 comma -1. Because the y value has to be the same. If you have a horizontal line, if you remember Hoy Vux, H-O-Y, so my 0 slope, my horizontal line has a 0 slope, and it's y equal to the same number. So it's going to be y equal to -1 here. So they both have to be -1. Then for point C, notice that if I have equal sides, I can drop a perpendicular down, and these 2 sides are going to be the same. So this is a perpendicular line. So then this is going to cut this side in half. So all I want to do is find the midpoint between -5 and +1. So if I add them up, divide by 2, I end up getting -3. No, that's not negative 3.